Bible says the universe began with the thought, "Let there be light." Mainstream science believes the universe's beginning was more intricate and gradual than people think. What if the light from millions of stars and quasars could never reach us? What if the cosmos was so dense that light could be trapped? What if the light couldn't be separated from the darkness? Believe it or not, the universe was once dark despite all the dazzling objects in it, until it wasn't. This film may explain how the universe became transparent. Hello and welcome to Z. Don't forget to subscribe and click the bell icon. Imagine a room full of clear tarp curtains with few spaces between them. With effort, you can move between them, but there are too many to be useful. If you put light bulbs between the curtains, the light they emit will be contained. From the outside, the early cosmos looked dark, although it contained sources of light. As we discussed before, our understanding of the universe depends on light's capacity to travel endlessly over billions of years to reach us. This part of the universe prevented light from traveling far. We know nothing about it, but then it became transparent and light could travel billions of light years. This video attempts to answer that question. Scientists have spent years studying the cosmic dawn. Before the light arose on the horizon of the universe, we couldn't crack this code. Back to the Great Bang, which happened throughout in space, not only at a specific spot as many imagine. The universe expanded like an egg on a course. Because the cosmos was hot and dense, all its matter, mainly hydrogen and helium, was ionized. Back then, there wasn't much variety among elements because all the light was high energy. When electrons sought to hit on photons, they were shunned away like creeps, so the universe was like a miasma. Imagine a cloud of completely impenetrable gas so dense in winter that you can't see across the street. If humans existed then, we would have lived in endless foggy winters, but not for long because without sunshine life wouldn't have lasted long. If you lived in this miasma, everything would be opaque since you'd only see air, which would block your view of anything else. Here's the agonizing part. It happened twice in the history of the universe. Scientists call the second event recombination. But why did the first stars and black holes arise a billion years after the Big Bang, knocking electrons off hydrogen atoms and lighting the gas? But as the universe expanded and cooled, photons lost the energy to ionize hydrogen atoms. This allowed electrons to reach protons, resulting in neutral hydrogen. Electrons and protons were merging for the first time, so why recombination? Well, the great thing about science is that you may be incorrect, as scientists have demonstrated again and again. They use Latin to name plants and animals, honestly. The neutral hydrogen created by combining electrons and protons is particularly good at absorbing light, even though the universe's density is decreasing owing to expansion. No light, and the universe was opaque. This epoch is known as the Cosmic Dark Ages. The universe lasted that way for a long time, until new things that could shoot ultraviolet light helped ionize it again. Reionization was different this time. The universe had expanded enough that photons or light rays could travel great distances without being absorbed. Space became transparent and the fog dissipated, but we overlooked one thing. New things that could shoot forth ultraviolet light caused reionization, but when and why? If reionization hadn't happened, the cosmos would be different. Most galaxies and stars wouldn't have existed even now, when most of the universe's gas is ionized and humans can see far. Just look up at night. All those stars are trillions and trillions of miles away from us, but we have no idea what caused it and when exactly did it happen. This mystery is a key piece in the puzzle of the universe's history for astronomers, and they're dying to find out to better understand the universe, a puzzle they haven't been able to solve for decades. When galaxies began coalescing out of the murk, gargantuan black holes became their core and galaxies formed around them. Since black holes have existed, matter has been falling into them and piling up in a disk that orbits the black hole at close to the speed of light and blasts out high-energy ultraviolet, X-rays, and gamma rays. Known as quasars, these galaxies are billions of light years away. Due to the expanding cosmos, the light from quasars comes with stretched wavelengths. Red shifting is a well-known phenomenon, but that's a positive thing since it helps us understand how far away the quasar is and how long after the Great Bang we observe it. Remember that light travels at a fixed speed, thus the more distant anything is, the more it's red-shifted and the further back in time we view it. Quasars are so powerful that if we were seeing one before reionization, it would have ionized hydrogen around itself instantaneously, allowing light to get out. Light rays are on their own from here on, and if they travel through a cloud of neutral hydrogen, it was before reionization. This cloud would have absorbed the light, but the red shift of a wavelength gap in the quasar's light would tell us how far away the cloud is and how far back in time we're gazing. This is like a telecom company transmitting data over a damaged fiber link to find the break. Clouds far away are neutral and unionized, but after reionization we don't see them since they weren't there to absorb the quasar's light. So how to find out when reionization happened and then what caused it in principle? We merely need good spectra of distant quasars to divide their light into wavelengths. We've looked for 3 decades but haven't discovered good spectra showing absorption at various wavelengths that disappears at low enough redshift. We'd need incredibly strong quasars at such a great distance that they'd be faint. On top of that, we'd need a very large telescope with long exposures, which should be achievable with the Roman telescope, but we don't know what the universe was like then. Worldwide team of astronomers believes they may have uncovered the answer after studying 25 distant, brilliant quasars from the XQR30 survey, using archived observations of 42 more from 2 different observatories and analyzing 67 quasar spectra. They assume they know cosmic dawn's end. The reionization occurred 1.1 billion years after the Big Bang 12.7 billion years ago, but that's only half the explanation. We also need to know what caused it. Sarah Bossman directed the Max Planck astronomy team. Has 2 suspicions in mind: either the reionization was triggered by the quasars they investigated or by the development of gigantic, hot, bright stars. But who was accountable, or was it a team effort? The team feels timing would assist, but here's the difficulty. Former research say reionization happened 200 million years ago. If the new math is true, it would also check the time needed for supermassive stars to form, but that's a big if. Is the enigma finally being solved? Only time will tell as more observations are made. New telescopes will help the theory. The wait to grasp the universe was worth it. Tell us what other cosmic puzzles keep you up at night, and thanks for watching Z. Please like and subscribe if you liked the video.